Hey guys, today what I want to do is to review adding and subtracting fractions. You're like, well, wait a second, we've been doing decimals. Why are you talking about fractions? Well, guess what? Chapter 4, that's where we're going next, and it's all about fractions. So I wanted to go over some of the material that you probably have covered in your prior years and make sure that you guys understand all the different facets of being able to add or subtract fractions. So the first thing we're going to do is talk about dealing with numbers, okay? So first off, let's talk about changing mixed numbers. So that's something like 1.5. I'll get that a capital M. Looks better. To improper fractions. And hopefully you'll understand the difference between. So an improper fraction would be like 3/2. Okay. So let's start with our mixed number, 5 1/4. Okay. So we have 3 steps, and it goes bottom up. That's how it works. So we're going to start by multiplying the denominator, which is the number in the bottom of a fraction, and the whole number. Multiply denominator by whole number. That's our step 1. Now we're moving up. Our step 2, so let me write this. Put a little symbol there. So this is a multiplication step. Then we add. So we're going to add the numerator, that's the number on the top of the fraction, to the product. Remember, product is the answer to a multiplication problem, and we got a product when we multiplied the denominator by the whole number. Okay, so now we have a single number. And then what we're going to do is this is going to become the numerator. So we did 4 times 5 is 20. And then we're going to add the numerator, so that's 21. So then we're going to have add the denominator, or the denominator stays the same. Denominator stays the same. It's a long word. Okay, so we got to 20, and then, or 21, and then the denominator stays the same. It stays at 4. So let's do this off to the side. Let's label our pieces. So let's say we have 3, and then 4. Okay, so the 3 is called the numerator. The 4 is called the denominator. Okay, and the fraction bar is actually a fancy way of saying division. Okay, all right. So improper fraction, let's write down that definition since we were using that word. So an improper fraction means that the denominator, here, let's use those same colors. Is less than the numerator. So we're always expecting the denominator to be bigger, but it's less than, so that's not what we expect. That's improper, okay? So let's talk about how do I go the other direction. So we're going to be changing improper fractions to mixed numbers. And remember in the notes, if you guys ever get tired or if you need to take a break, just pause it and then you can come back when you're ready. So let's take this guy, 43/8. Well, remember what I just said about the fraction bar. It actually is equal to, or it means the same thing as to divide by. So this problem is really 43 divided by 8. And if we changed it into the fraction house, it would be 8 dividing into 43. Now remember we talked about you don't get to write r anymore, no remainders, and we talked about in chapter 3 how to write the remainder as a decimal. Well, now we're going to show you how to write the remainder as a fraction. So first off, we have to get back into our math facts. 8 goes into 43 5 times, which is 40, and there's a leftover 3. So that 3 is going to go in the numerator, and the denominator stays the same. So what we have here, I'm going to just kind of talk about the divisor is the same thing as the denominator, because you're dividing by the denominator, okay? And then the remainder is the numerator of the fraction. And then whatever we were able to divide, that's going to be the whole number part, okay? Okay, I think I'm going to go to my next screen, but I would still be on the first page of my notes. So I want to talk about another key component with fractions is something you always do. So I don't want to hear you say, do I need to simplify my fraction? It's like you asking, do I need to breathe? Yeah, you need to breathe all the time. Otherwise, you're dead. Okay, so do I need to reduce my fractions? Yeah, every single time. So let's talk about simplifying fractions. And how you hear this is often something like this. Reduce to lowest terms. Or write in lowest terms. Okay? So basically what we're going to do is we're going to look at our fraction and we're going to ask ourselves, are there any factors, those are numbers that divide evenly into a value, are there any common factors between my numerator and denominator? And the answer is yes or no. And if it's yes, you're going to divide it out. So let's give you an example. Let's say we have 48/60. Okay, so there's all sorts of ways to do this. So I'm just going to write down some steps. So 1, we're going to look for a common factor. In the numerator and denominator. Now as we get through this chapter, you're going to notice that I'm going to stop writing numerator all the way out, and I'll abbreviate it, and I'll also abbreviate denominator. But for the time being, since this is a new, we're going to just keep writing it out. So we're going to look for a common factor in the numerator and denominator. So first thing I'm always looking for, are the numbers even? If the answer is yes, then I'm going to go ahead and divide out a 2, because 2 can divide evenly into anything. Okay, so I do that, and let's see what I have left over. 48 divided by 2. 2 goes into 4 twice evenly, and into 8 4 times. 2 goes into 6 3 times evenly, and then there's a 0. Okay, so you can ask, is there something else? So let me write down our second step that we've been doing, and then we're going to divide out common factors. The common factor. We'll only do one at a time. And then we're at the step where we need to repeat the process. So look for a common factor in the numerator and denominator, divide out the common factor. Oh, I wrote factors. I don't even want to write factor. There we go. Much better. And then we're going to repeat the process until there are no more common factors than 1. So you can always have a common factor of 1, but if you factor out a 1, it really doesn't change anything. Okay? All right, so let's go back here. I notice that the numbers are still even, so I'm going to divide out a 2. And that's going to give me 24 divided by 2 is 12, and 30 divided by 2 is 15. Now there's so many ways to factor. Order of how you pull things out, so on and so forth. Ooh, let's see, what goes into a 12 and a 15? Ooh, a 3 does, so I'm going to divide out a 3. And 12 divided by 3 is 4, and 15 divided by 3 is 5. Now you might have heard from teachers that if the numbers are, I think they use the words next door neighbors, meaning they're 1 apart. So if your numerator and denominator are 1 apart, you can't simplify them anymore. Okay, now does that happen every time? No. Now look what it took me. It took me 1, 2, 3 division steps until I got to a reduced fraction. So what I want to share with you is a strategy I love to use. And this strategy is prime factorization. And you might be used to it being called like a factor tree. Okay, so here's what prime factorization is. I'm going to take my two numbers, 48 and 60, and I'm going to just come up with 2 factors for each number. And then keep breaking down until all I have are prime numbers. Now, prime numbers, remember, they have only 1 times the number are the only factors that it has. So I know 4 goes into 48 12 times because I memorized my math facts. Now, the number, so let's write that number. Let's write that over here. I'm going to write prime number. A prime number means a value that has exactly 2 factors. And those 2 factors are 1 and the number itself. Okay, so for example, 2 has only 2 factors, 1 times 2. So factors are numbers that we multiply. So those are the only 2 numbers that will give me 2. And even if I rearranged them, it would just be 2 times 1, which is still the same 2 numbers. Now, any number that isn't a prime number would be called a composite number. When I was growing up, I played tennis, and I had a composite racket, and so that meant it was made from different materials put together. So it wasn't a wooden racket, it had a mixture of other kinds of products. So a composite number has 3 or more factors. Okay, so for example, we'll give you 10. So I can do 2 times 5. That's one set of factors that give me 10. But I could also do 1 times 10. People always forget those as being factors. So in other words, it has 4 factors. So you might wonder, how can a number have only 3 factors? Well, it's a special kind of number. 2 of its factors are 1 times 9. And then we have 3 times itself. So when I'm counting factors, I only count each unique number once. So this one would have 3 factors. Okay, so let's look at, I'm going to move that 60 over from our prime factorization, because we're going to need a little bit of room here. I stole a lot of room. Okay, so I'm going to continue with my 48. So 4 is not prime, because it's 1 times 4 and 2 times 2. But 2s are prime numbers. Remember, we just talked about that over at prime. So I'm going to circle up, saying to myself, I don't have to go any further. Okay, well, 12, well, I can either say it's 3 times 4, 2 times 6, doesn't matter, but I know 3 is a prime number, but 4 isn't, so I'm going to have to break it down. Okay, so if I want to figure out prime factorization way of simplifying a fraction, I'm going to take that 48, and I'm going to take those prime numbers that are all circled at the bottom, and I'm going to write them in order from least to greatest. So I had 4 2s and then a 3. Okay, let's do the 60 now. Let's do orange. So we've got 2 times 30. I don't know why my head went that way. Let's see, 5 times 6. A lot of you probably did maybe like 3 times 20 or 10 times 6. So we have so many choices here. And then we've got 6 is 2 times 3. So now we have all prime numbers. So 60, again in order, would be 2 times 2 times 3 times 5. Now, one thing we were mentioning the other day is that the dot represents multiplication. Okay, so let's see if you guys remember this piece. If I have a number and I divide it by itself, what do I get? Yep, you're right, you get 1. So 2 divided by 2 is 1. Here's another partnership of 2 divided by 2 is 1. Here, they don't have to be directly over each other, but 1 in the numerator, 1 in the denominator, 3 divided by 3 equals 1. So let's see what we're left with. So we have 48 over 60 is equal to 2 times 2 over 5. And if we simplify that, we get 4/5, which is what we got over here. So that's just a different way of solving. All right, so let's get to the matter of adding and subtracting fractions. What are the rules? So this might be a good time to take a break if you need to. Okay, because we've already gone about a little less than 20 minutes. Okay, so let's go over step by step. So number 1, we must have a common denominator. Now I got to remind you that the rules for adding and subtracting are the same for each other, but they're different from the rules for multiplying and dividing. So must have a common or same denominator. If you're lucky, they start that way. If you're not lucky, you're going to have to make them that way. Okay? So next up, create equivalent fractions. And that's a fancy way, create equivalent. I didn't spell that right. Equivalent fractions. That's a fancy way of saying two fractions that have ultimately the same value, but they don't look the same. Okay? So create equivalent fractions using a common denominator. And then I'm going to demonstrate this so you see what I'm talking about. Okay? Once we have common denominators, then we get into the math bit. So we're going to add or subtract the numerators only. Add or subtract the numerators only. Okay? And then we're going to, the denominator stays the same. So nothing changes now with that common denominator at this point. But we do need to check for one more thing. And that one more thing would be to simplify the answer some people may say the words reduce to lowest terms. That's what it means. That's another way of saying it. And only if you can. Sometimes you're going to get an answer that is already reduced and you're done. All right, so let's do some practicing. Directions say simplify. And our first problem, we have 2/3 plus 4/27. Okay, so I need to come up with a common denominator. So the first thing I always try is there's something that I can multiply the denominator by that will give me the smaller denominator that will give me the bigger denominator. And I went, well, wait a second, yeah, if I multiply 3 times 9, that's going to equal 27. But if I multiply the denominator by 9, I got to multiply the numerator. Remember, fair is fair. So that's going to become our common denominator. And so now these are our fractions. We're going to get 27 as the denominator for each of them. The second fraction's 4 doesn't change. The addition doesn't change. The only thing that does change is what 2 times 9 is, and we get 18. So now we go ahead and add only the numerators. So we're going to add only the numerators. So we're just going to add this part. So 18 plus 4 is 22 over 27. And then let's see, 22 has factors like of 2 and 11, but neither 2 nor 11 can go into 27, so I'm done with this problem. All right, let's try the next one. 15/16, and we're going to subtract 5/8. So again, I'm going to check if the smaller denominator goes evenly into the bigger denominator, then I have a common, that the bigger denominator will be the common denominator. And sure enough, if I multiply 8 by 2, it becomes 16. So to be fair, I have to multiply the numerator of the fraction also by 2. So I still have 15/16, I still have subtraction, but now this new fraction is going to change completely. So it's going to give me 16 in the denominator, but in the numerator, I'm going to end up getting 5 times 2 is 10. So now I go ahead and I subtract 15 only here. Let me box that up. 15 take away 10, and that's going to give me 5 over, and then 16. Now 5 is prime, and it doesn't go into 16, so that's as far as I can go. So far I haven't had to reduce. All right, let's try mixed numbers. 1 1/3 plus 3 3/5. Well, I actually like solving these problems vertically. I like lining up the whole number with the whole number and the fraction with the fraction. I think it's a lot easier to solve it this way. So, So here, 3 can't go into 5. So what we're going to do is just multiply those two denominators together. So that's going to be our common denominator. So I'm going to write over here, common denominator is 3 times 5 equals 15. So I multiply top and bottom of the first fraction by 5. And I'm going to multiply top and bottom of the second fraction by 3. The reason why I do that is so both fractions will get the denominator of 15. And let's see, in the top one, we get 1 times 5 is 5. And then in the bottom one, we get 3 times 3 is 9. Okay, now remember this is an adding problem. So here's how I'm going to break it down. I'm going to add my fractions, and I'm going to add my whole numbers. So 5 plus 9 is 14, so I get 14 fifteenths. Now, that's a proper fraction. My numerator is less than my denominator. I also know I can't simplify because the numbers are next door neighbors. Now I'm going to add the whole numbers, and 1 plus 3 is 4. So my answer is 4 and 14 fifteenths. All right, last one, I promise. Another mixed number, but we're going to subtract. So again, your book is going to give it to you horizontally. I, again, like to change it vertically. I just think it's easier to solve that way. So I don't have a common denominator, so the easiest way to come up with a common denominator is to multiply the two denominators together. So that means I'm going to multiply the 4 times 9, but if I multiply the denominator by 9, I got to multiply the numerator by 9. And then I'm going to multiply on the bottom the denominator by 4, and I have to multiply the numerator by 4. So now I'm going to, again, look at this in two kind of components. So I'm going to keep the whole numbers off to the side, and then I'm going to end up with 9. Oh, come on, let me write. 9 in the numerator. 1 times 9 is 9. The denominator is 4 times 9 is 36. And then we have, and this is the worst problem. Usually, remember in our notes, the last one is what I call the doozy. I'm giving you a doozy. So 7 times 4 is 28. And then 9 times 4 is 36. So here's the problem. This is a subtraction problem, but I can't do 9 take away 28. So this is when I do something called renaming. So I'm going to go ahead and take 1 away from the whole number. It's going to leave 4 whole numbers together. And to my top fraction, which is too small for me to do my math, I'm going to add a fraction to it that equals 1 whole. Now, it's only way I can add them is if the denominator matches. The only way then the fraction can equal 1 is if the numerator and the denominator are the same. Oh my wordy, right? So now I've created a fraction, still with a denominator of 36, and 9 plus 36 is 45. Now I'm going to just move this guy over. So now, can I do 45 take away 28? And the answer is yes. So I'm going to go ahead and do that, and I'm going to get 5 take away 8, can't do, so I'll rename. So 15 take away 8 is 7. 3 take away 2 is 1. And I get 1736. And then I have to deal with the whole numbers. And I get 2. So I put them together, and I get 2 and 1736. Alrighty. Hopefully this is reminding you of things. I'll talk to you later. Bye now.